Hello, my dear students. Today we start our medical physics for medical science student, and we start from physics, what like a fundamental science, what the subjects of physics, what it learned. It concerned with the fundamental principles of the universe. Foundation Physics is the foundation of physical sciences. Physics has simplicity of fundamental concepts. Yeah. So physics divided into 6 major areas: classical mechanics, relativity, thermodynamics, electromagnetism, optics, quantum mechanics. Yes. What is the objectives of physics? Objectives of physics is to find the limited number of fundamental laws that govern nature phenomena. Second, to use these laws, develop theories that can predict the result of future experiments. Yes, and we're trying to express the laws of the language of mathematics. So the mathematics is our main great apparatus. Mathematics provides the bridge between theory and real experiment. Theory and experiments should complement each other. Then when discrepancy occurs, a theory may be modified or new theories formulated. A theory may apply to limited conditions. Example for this: Newtonian mechanics is confined to objects traveling slowly with respect to the speed of light. And we're trying to develop a more general theory this way. Also, medical physics is defined as application of physics to the needs of medicine. Yes, it's our subject, biophysics, medical physics for medical students. Aims of the medical physics: it's the application of the concepts and methods of physics to understanding the function of human body in health and disease. So first part will be physics of the body. It's to understanding physical aspects of the body, such as forces on and in the body, work, energy, power of the body, heat, blood flow, respiration, electricity, circulation, and hearing. Yes. Application of physics in medicine. Medical physics techniques are used for the first one. It's like stethoscope. Yes, something to hear what happens inside our emptiness of our body, inside the lungs, for example, how the heart works, and so on. Good doctor could hear actually the inflammation of the lungs. Yeah, even without stethoscope. Yes, actually, it's a very ancient technique, but it really works now. Manometer, blood pressure, really good technique, very useful in everyday medical life. Sphygmomanometer, another good technique. Electrocardiograph, ECG. Yes, every hospital have this. X-ray diagnostic, the best diagnostic, the cheapest diagnostic is that we even have. Electroencephalograph. Yeah. Electroencephalograph, EEG, electromyography, EMG. Thyroid function using. Yes, could be like some special type of radioactive isotope to making research of thyroid function, actually, because it's like iod very much and contaminate, but the another isotope radioactive also contaminate very good, and it actually we have technique what really good showing the radioactive isotope of iod. Computer tomography, ST scan, very useful in the some problems of the brain, even with the sheer heart attack, and you can you need to check. Now it's very widely used when we have the problem of inflammation of the lungs, and we need to understood what the percentage of the breakage of the lungs because of coronavirus inflammation. Ultrasound tuning fork, very good technique, also could show us the belt of your inner organs and systems. Magnetic resonance imaging, MRI, yes, the best technique to show us the problem with the brain, for example, or the problem with the, your bones. Non-invasive, yes, don't forget this, not invasive. If you did not have the cardio stimulator or sensing metal parts of your body, so flow meter, spirometer to study the function of the lungs, audiometer, optics, laser, gamma camera to study the function of the kidney, liver and lungs. So many of our physical methods to have an experiment with the body of the human. Therapy, different type of therapy. Radiotherapy, yes, I already told you about the radioactive isotope of iod. Cobalt 60, Co 60 it's called, but it's little bit not usable right, like cobalt 60 in this way, but it's normal. It's really works in American literature. High voltage therapy, ultrasound, yeah, we have ultrasound therapy, infrared therapy to warm something, if we say in the more non-physical way explanation of this world. Radio frequency, something like radio frequency therapy, heating therapy, and laser therapy to destroy something, problems with the skin, for example, something like that, papillomas. Another way of problems with the epithelium of the skin. Patient monitoring could be ECG, spirometer, breathing. Yes, it's very highly used now, and the problem of the breathing after inflammation of the lungs, connecting with the problems with the coronavirus. Blood pressure and thermometer, it's everyday use diagnostic. So what measurements do we have to use to describe the nature of phenomena? Each measurement is associated with the physical quantity. We need defined standards, actually, to measure something, and we need characteristic of standards for the measurements. Really accessible, possess some property that can be measured reliably, must yield the same result when used by anyone anywhere. It cannot change with time. Yes, some standards of fundamental quantities, standardized systems. Yes, so we need to agree upon by some authority, usually governmental body, system international of units, C, yes, SI, main system that will be used in this text in my presentation, because the governmental international system, governmental measurements units. It was agreed in 1960 by International Committee. Yes, and here is that the fundamental quantities and their units. Yeah, we have quantity, something like length, mass, time. Here is that temperature, electric current, luminous intensity, and amount of substance. Yes, and we have symbol if SI. C units. Yes, it's something like length, it's a meter. M, letter, symbol, mass, it's a kilogram. Yes, kilogram. Do you remember that kilo is 1 on the multiplying on 10 in the power of 3. Yes, it's 1000 of grams actually. A time, it's a second, S. Temperature is Kelvin, K. Yes, remember that scale that we have 273 degrees plus. Yes, to receive this our different scales about Celsius, Fahrenheit, and Kelvin, and we use Kelvin in this way, in these units. Electrical current, ampere, A. Luminous intensity, candela, CD, and you can see it actually at some good prescription of the this light bulb. Yes, the energy saving light bulb always have the prescription what temperature of the heating, actually the same what heating we need to push to give the energy, temperature energy to the body to receive such luminous energy with the some candelas. So and the last one is amount of substance, a mole, amount of substance, amount of the how much molecules in the some objem, in some volume. Yeah, okay. In mechanics, 3 fundamental quantities are used: length, mass, and time. All other quantities in mechanics can be expressed in terms of the 3 fundamental quantities. Derived quantities can be expressed as the mathematical combination of the fundamental quantities. Example, it's the area. An area is the product of 2 lengths of the body. Yes, if you have squared body, for example, you have a product. And you have also this part of the area and perimeter in the test. So the test shows us not everybody understood that perimeter with some intersection of the body didn't change. Actually, perimeter is the same. The square is changing when you take the part of the body from it. Speed, a ratio of a length to a time interval. And the density, yes, it's a ratio of the mass to volume. I must say that speed, we will use it when we have explanation of the derivative system and differentiation. We already know that speed of changing of some volume will be our derivative, will give us differential of the some volume. Yes, and density is a mass divided on volume that the masses have in the universe. Prefixes here, we need to use prefixes. We already use them every day, but we forget what does it mean. Prefixes corresponds to powers of 10. Yes, so it's every time it's a 1 multiplying on the power of 10, and in some powers, these powers explain the measurements, and of some values. Each prefix has a specific name and has a specific abbreviation. The prefixes can be used with any basic units. They are multipliers of the basic unit. Examples: it's 1 millimeter, it's equals to 1 multiplying on 10. Here is the 1 is disappeared somewhere. Yes, to have more easiest way to write the explanation, here is that 10 in the power of minus 3 meter. 1 milligram, yes, is 10 in the power of minus 3 gram. Something like that. So we have prefixes for powers of 10. Here is our kilogram, yes, kilometer. Here is our megawatt. It's 10 in the power of 6. Так, гига. Так, проверяем. Как проверить?
Как? Сохранить. Нажимая 5, тормознуть.
Где вот тут?
Ну да.
Стоп. Остановить или завершить?
Завершить.